Hello everyone, welcome back to another exciting chemistry lesson. In today's lesson, we are going to learn about oxidation and reduction and how to calculate the oxidation number of an element in the compound. We are going to have some rules and then we are going to solve some problems. So let's go for it.
By the end of this video, you will be able to calculate the oxidation number of an element in a given compound. So let's go for the rules to calculate the oxidation number. The first rule is that the oxidation number of an atom in an element is 0. So for example, if you have magnesium, it's just the magnesium atoms. So it's always going to be 0, and oxygen molecule, it's always going to be 0. So an element will always have an oxidation number of 0 when it is in an uncombined state. We also have another rule. It says in an ionic compound, the oxidation state of an element is the same as the charge of its ions. So what does it mean? If you take up NaCl, that is sodium chloride, an ionic compound, we have Na having Na plus and Cl having Cl minus. The oxidation state of hydrogen in most of the compounds is +1, and the oxidation state of oxygen in most of the compounds is -2. Also, we have the oxidation state of halogens in most of the compounds is -1. So if you know all of these oxidation state, this is going to be the same for most of the compounds. Once again, I repeat, it's going to be for most of the compounds. That means there are certain exceptions wherein the oxidation states are going to change. But for our calculations, we will consider the oxidation numbers for hydrogen, oxygen, and halogens as +1, -2, and -1, respectively. And the most important rule is that when you add the oxidation states of elements in a compound, it is going to be 0. So the oxidation states in a compound adds up to 0. So we have another rule which says the oxidation numbers of atoms in an ion add up to the charge on the ion. We will see certain examples wherein we come across polyatomic ions and how to calculate the oxidation number of elements in such a polyatomic ion. So it's going to be, the addition is going to be the charge. Okay, let's come up with the examples. So the examples we have, the first example, we need to find out the oxidation number of carbon. So carbon is underlined, and this is carbon monoxide. So how do we solve this? So we start off by taking the unknown, that is the carbon. We do not know the oxidation state of carbon. So let us keep the oxidation number of carbon in carbon monoxide as X. So we have to do a bit of mathematics here, and it's going to be simple mathematics in order to find out the oxidation number of the underlying element, that is carbon, in carbon monoxide. So we have already called the oxidation number of carbon as X, and we also know the rule that the addition of the elements, that is the oxidation number of elements in the compound, should be equal to 0. And this is 0. And it is not a charge because carbon monoxide is not having any charge. So when you add up, so plus and minus, X becomes X minus 2 is equal to 0, implies X is equal to +2. You know that the -2, when it goes on the other side, it becomes +2. So the oxidation state of carbon in carbon monoxide is +2. We have another example, that is sulfur and sulfate. So we have an example here wherein there is a charge in the polyatomic ion. So we see that there's a charge. So if we remember the rule, it says that we need to add up the oxidation states and it should have the sum as the charge. So once again, we repeat the same procedure of calling the underlined element, the oxidation number of the underlined element as X. So let the oxidation number of sulfur be equal to X. We start off with the formulation. So x plus 4 into minus 2. Minus 2 because oxygen in most of the compound is minus 2. And 4 is due to 4 oxygens in sulfate. So as we proceed with calculation, 4 into minus 2 should give you minus 8. So x minus 8 is equal to minus 2. That should give you x as equal to 6. That is plus 6. So the oxidation state of sulfur in sulfate is going to be plus 6. We have another example. To find out the oxidation state of carbon in carbonic acid. Carbonic acid is given as H2CO3. So let us go along with the same procedure. So let us call the oxidation number of carbon as X. And we know the oxidation number of hydrogen is plus 1 and oxygen is minus 2, as we have learned in the rules. So as we add up the oxidation numbers, this is going to give you 0 because it is not charged. If it was charged, then it would be equal to the charge, but this is not charged. That is why we have to add up. So we have 2 hydrogens, 2 multiplied by the oxidation number of hydrogen as 1. Then we have X, the oxidation number of carbon, and we have 3 oxygens multiplied by the oxidation number of oxygen, that is minus 2. So we get 2 plus X plus 3 multiplied by minus 2 is minus 6, so that is equal to 0. So X should be equal to 6 minus 2. That is equal to 4. So X is equal to plus 4. The oxidation number of carbon in carbonic acid is plus 4. The next example is nitrogen in ammonium hydroxide, that is NH4OH. So we start off by taking the oxidation number of nitrogen as X. We know the oxidation number of hydrogen, that is plus 1, and oxidation number of oxygen as minus 2. So X plus 4 multiplied by plus 1. Plus, you have only 1 oxygen, so it is minus 2. Plus another hydrogen, so it's going to be plus 1. The whole sum should be equal to 0 as there is no charge in ammonium hydroxide. So let us simplify it. So we have X plus 4. Then we have plus and minus 2. So that should give you minus 2. And we have plus 1. That should be equal to 0. So if you further simplify it, we have everything given out here. So X should be equal to minus 3. It is simple calculation, so you should be easily able to solve this. So nitrogen as minus 3 in ammonium hydroxide. We have another example here wherein there is a polyatomic ion. This ion is called ammonium ion, NH4+. So once again, we start off with the oxidation number of nitrogen in ammonium as X. So you can simply write it as, let the oxidation number of nitrogen be equal to X. And then we can solve it. This time the sum should be equal to plus 1 because the oxidation number, the sum of the oxidation number should be equal to the charge. And NH4 plus has plus 1 as a charge. And we go with the calculations using hydrogen as plus 1 by the rules. So 4 hydrogens, so you're going to get 4. So X plus 4 is equal to plus 1. That should give you X as minus 3. So oxidation number of nitrogen in ammonium is minus 3. Another example with nitrogen is in NO3 minus, that is nitrate. The underlined element is nitrogen. So let the oxidation number of nitrogen in nitrate be equal to X. We also know that nitrate has a negative charge, so it is having a charge. So that the sum should be equal to -1. So X plus, we have 3 oxygens and the oxidation number of oxygen is -2. So 3 multiplied by -2, and that should give you the charge, that is -1. So X plus 3 multiplied by -2 minus 6 should be equal to -1. So what do we get when we take the 6 on the other side? So we should get X is equal to -1 plus 6. That should give you an answer of +5. So we can simply write it as 5. So the nitrogen, the oxidation number in nitrate is +5.
I hope you really enjoyed this lesson. Stay tuned for the upcoming lessons in oxidation. Till then, signing off, Edberg Soans.